Hello, welcome to a new video. We're gonna do this problem called 328 odd even linked list. Just to note that I did look over this before I went to the gym, so kind of do understand it a little bit, but let's just go into it as if I don't know anything. All right, so given the head of a singly linked list, group all nodes with odd indices together, followed by the nodes with even indices, and return the reordered list. So basically we're going to reorder. So we're gonna get all the odds first, and then followed up with all the evens in the linked list. Odd and even mean their odd indices and their even indices as if this was like a list, or an array, right? So and it says that the first node is considered odd and the second node is even, and so on. Note that the relative order inside both the even and odd groups should remain as it was in the input. So it means that it should be in order basically as they appear. You must solve the problem in O1 extra space complexity and O of n time complexity. Okay, so that's cool. All right, so just to go back, we know that our input's just the head of a single linked list, and then the output's supposed to be the same linked list, but reordered. We can take note that reordered, like what is it? What do we need to reorder, right? Well, we're gonna basically reorder their so their grouping, I guess. So odd, then even, retain position. Yeah. So retain position in order. In group. So yeah. And then what am I missing? Yeah, and then we're supposed to order by indices. Okay. And then let's note we must solve in O of n space and O of n time and O of 1 space. So that means we're going to use pointers. For some questions, I guess. I guess the question I would ask is, can the linked list be empty, or what's the min size of linked list? We can scroll down. The number of nodes in the linked list is in the range of 0 to 10 to the 4th. So we can say that no min size is equal to 0. Oh wait, so I guess yeah. So yes, min size is equal to 0. I don't think the node values matter as much because we don't really care about that. So yeah. So yeah, let's go through some examples actually of our own that we do to actually understand the problem. Make a Jamboard. I use this one, but let's just make another one. All right, so let's just make our own Jamboard or our own example. 2, 3, 4, 5. Right. So, yeah, so let's say that this is our input, and then we need to arrange it where the odds are grouped first, and then the even indices are grouped last. So, funny enough, or it's not funny. Conveniently enough that our indices are kind of matched. No, our values are just odd and even. So 1, 3, 5 are odd, 2 and 4 are even indices. So that's cool, I guess. Yeah. Wait, hold on. Let me double check. The first node is considered odd and the second node is even. Okay, cool. Yeah. So, yeah, we can rearrange this. So we need 1, 3, and 5 to be our first group. So 1, 3, and 5. And then 2 and 4, which are the evens. So this would be the input, this is the output. But yeah. What if it was just 1, 3, and 4? pretty much be the same thing, where we need to rearrange 1 and 3 to be odd, then 2 and 4 to be even, right? So to do that, we just here 2, 4, right? So that's pretty much it, right? So yeah, that's pretty much the input and output. We got that as an example, so we'll revisit these two later on once we're trying to plan out the code and what to do, right? So we already went through some examples, so let's just go ahead and kind of match what tools we can use to solve this problem. We can obviously use like a counter to keep track of indices, I guess, or indices. This should helps out with determining odd or even, right? And then we can have like pointers, I guess. Odd, even, then temp pointers. I don't know, just pointers to maybe help out with rearranging. Then let me think. I guess we could do like a while loop, iterate with while loop. I guess like while something is like next, no, while something next doesn't equal to null, something like that. I don't know. And then let me think. I was gonna use some if statements, maybe if statements, and then I'm not sure for what, but yeah. I think that's pretty much it. Like what we can do to solve this problem, or use to solve this problem. So let's just go ahead and kind of code it up, or kind of like get some pseudocode up. But before that, I want to make my driver code. And then I'm going to name this function to solve this problem. Get rearranged list. It's going to take in head. And then I'm just going to make our linked list node. So was it list node? Was it list node? Yeah, list node class. List node. It's going to take in wait, is it? How do I make a class? Yeah, self. Let's take in self. And value equal to 0. And then next is equal to none when we initialize it. And then let's go ahead and make our init, our constructor. And take in val and next. And self.val is equal to val. And then self.next is equal to the next that we're given. All right, so what? Oops, I'm not supposed to oopsie. This is not like, okay, cool. Okay, cool. No, I don't need that. Yeah, okay, I don't need that. Okay. It's been a while since I made classes in Python. Forgetting some stuff. But anyways, or in programming in general. But anyways, so we made our list node class. So this is our bare bones basically. Let's go ahead and solve this problem, or make some pseudocode of it, I mean. So what's the first thing I need to do? So we got user input from main. What do I want to do? I do obviously want to iterate through linked list, through input linked list. But how? So while what? I don't think the while condition really matters right now. I think we gotta figure out how to solve this problem in general. So I really do like my what I said pointers. So I'm gonna make an even, and then make an even, an odd pointer. So initially I'm pretty sure that odd will be here and even will be here. So I guess we can say what can we do? We can initialize odd and even pointers. So we can say that odd is equal to head, and then even is equal to head.next, which makes sense. But there's gonna be a case where our linked list is like, so I can yeah, so if statement. So in case length of linked list is less than 2, I guess, or less than equal to 2. So I can say if. So if linked list is less than equal to 2, let's just say we have this linked list, right? I think it's safe to say that we can just return. We can just return linked list or return head, right? I'm pretty sure because they're already in order because this is odd and this is even, right? That makes sense, right? And that's before we go into the while loop and stuff like that, so that's fine. So yeah, this makes sense. They're already arranged in that order where odd goes first and even goes last. So yeah, that makes sense. Now that we solved that, let's just go ahead and try to solve this problem using our head, I guess. So let me think. So in a linked list, there's the point like this, right? Initially, 1, 2, 3, 4, 5, right? And then we want to rearrange it where our end result is basically this. I erased it, but 1, 3, 5, and then 2 and 4. So yeah, we kind of want to make it like that somehow, but how do we do that? Well, first, we obviously want our odd to point to the next one. So odd wants to point there to that 3, and that 3 wants to point to that 5, right? And then this even wants to point here, right? So how do we do that? Well, we're gonna go through our while loop, but in order to like count if we're odd or even, we need to set up a counter. So I guess we can also initialize counter. So initialize a counter. So int var counter. This will keeps track of odd or even. Yeah, I even said it here. Good thing I caught it. So we're gonna have a counter variable. So counter is equal to, say, initialize it to 0, right? Yeah. So let me think. Yeah, that makes sense, I guess. So in our counter, I don't know what value it would be initialized to, but I think it makes sense. So I guess while we, hmm, hmm, maybe 1. I think, yeah, 1 makes sense because we're gonna start here, right? So I guess as we iterate through the linked list, we say that odd points to here, right? Points to even dot next. So I guess we can say like odd dot next points to even dot next. Yeah, that makes sense. And then I guess we can say that we can move odd here to where we pointed at. So odd is equal to odd dot next, right? And then yeah, that makes sense. We start here, I guess. And then what can we do? And then I guess our counter gets incremented to 2, right? Because we're here now, I guess. And then now even says, I'm going to point. Oh, before I say that, so when I say that odd points to evens next, we're basically, yeah, when odd's next gets points to evens next, we're going to erase this and then basically put our next points to here, to this 3. And so that 1 points to 3, which is kind of what we have here, so that's good. But how are we going to make this point to here, right? Make it look like this. Well, we can basically say that we can say that 2, or we can say that even.next points to odd.next. And then, so yeah, that makes sense. So even.next gets points to odds.next, which is this 4. And then now we can say that even's right here. So now even is equal to even.next, right? That's cool. And that's one loop. So that's one loop, which is interesting. Because if that's one loop, then are we even counting the while loop? I'm not sure what we can use for this while loop. Do we even need this counter? I'm not even sure if we do need it at all. So we can keep looping until something is null. But I'm not sure what could be null. Maybe it could be if even's null. It could be either or. We'll see. And then let me think. Yeah, so I think this is good what we have here. Odd.next equal to even.next. Yeah, it's kind of what we did right here. And then for this iteration, for our third iteration, we can say that odd. No, this is our second iteration. This is our second iteration. Because in one whole iteration we do all this, what we just did. Then I guess in our second iteration, like okay, we go back up here. Odd.next points to even.next. So odd.next points to evens.next. Cool. Then odd is equal to odd.next. So we move the odd right here, right? And then now, we say that even.next equal to odd.next. So even.next equals to odd.next. Odd.next is null. So we'll see what happens. So it's just right here. Right? And then even is equal to null. Right? Right? So that's cool, I guess. And then here we're left with the odd pointing to null. But here's what we have right now. So we just have this. We have this. This is what we have right now. We have 1 pointing to 3, 3 pointing to 5, and then 5 points to nothing, and then 2 points to 4, right? So this is what we have now. But we need it to connect to 5 to 2 somehow. So we need to make it so like this 5 points back to 2. So that's very interesting. What we can do, I guess, is we can make like a pointer, like I guess like even head, I guess, because that's where the head is, I guess. So even head. So then I guess once we reach null, odd dot next is equal to even head. And then from there we can just return head. Right? Like that makes sense. And so that's how we're going to kind of loop it around, I think. Like that makes sense. I just gotta code it. And one thing that I'm kind of confused on is how are we going to code this while loop? Like what's the condition? Could the condition be while even is true? Or like while it's not none? Because that could be the case. Because in what we did here, all we did here, Odd points. I mean, even's out of range, or it's like it points to null. So that kind of makes sense. That makes sense. And then we wouldn't go through this loop anymore, right? But let's try a case where odd is null. Is there a case where odd is null at the end? Because this was an even. Yeah, this was an odd linked list. Let's try even. So we're gonna do this one. So yeah, let's see what happens here with our algorithm. So okay, let's get even and odd pointers, and then we know that we're gonna have an even head where this 2 is. So boom, make it smaller. Even head's right there. All right, so we know even and odd start here. Yep, even, yep, they do start there. Then I don't think we need this counter anymore. Then we do while even is true, or while even's not null. We're going to do odd dot next points to evens dot next. So what color did I use for odd? I use yellow or orange. Okay, so odd dot next points to even dot next. Oh wait, actually I should make the lines for the pointers. Okay, so odd dot next points to even dot next. So evens next is right here. So odd dot next, we're going to remove where it points to and make it point to evens dot next. Cool. And then now odd is equal to odd dot next. Cool. Right. And now even dot next points to even dot next points to odd dot next. So even dot next dot next. So we're going to remove its next points to odds dot next, which is this 4. Okay. And then we're going to say that even is equal to evens dot next, which is right here at this 4. And yeah, so so now we have it so that 1 points to the 3, and then 2 points to the 4. Now we need it so that this 3 or the odd points to even head. Yeah, so once you remove this, so we're out of the while loop somehow. I think I need to write it so it's either like even, even, or even dot next. No, even and even dot next. Yeah, that makes sense. In this case, it was even. So it needs to be where both even, where even is null. No, where even is not null, and where its next is not null in order to continue iterating. So I think this makes sense because even though even's not null, even's next is not null, so I won't go through this while loop at all. So that makes sense. And so at the end, we're going to say odd dot next. There's odds right here, and it's pointing to this 4. But we're going to say that odd dot next points to even head. So we're going to erase this pointer and make it point to even head, which is this 2. So now we finally completed this loop, and we can just return head. That makes sense, right? Let's do a case where it's smaller. I just want to make sure like we got it down right. Let's say it's 1, 2, and 3, right? So the end result's going to be this. Going to be 1, 3, 2. I just want to make sure. That we got. I know that this algorithm works, but I just want to make sure that this while loop condition works. But be back. All right, I'm back. I'm pretty sure I was testing this how it would go. So we always needed an odd and even. Pointers. Then we will need a temp. No, we need an even head. Make it small, and it starts here, right? Odd and even, and we're going to test if this is the correct while loop condition. We will do. All right, so let's follow our algorithm. So while even and next is true, that's true. Odd.next points to evens.next, so it's here. Okay. And then odd points, odd gets is that it's next. And now even.next points to odd.next. Even.next points to odd.next, which is non-existent. So boom. Then even equals is now at even.next, which is nothing or none. And then now we reach the case where even and even.next are both false. They're basically both null. So yeah. So yeah, I think this will work. Yeah, they're both false, so it wouldn't run. So now, while this while loop, now we say that odd.next points to even head. Odd.next points to even head. 2, 3. Yeah. Okay. Makes sense. Yeah, okay. So yeah, that's awesome. So let's go ahead and code this out. So this makes sense. What I'm gonna do is I'm just going to basically copy paste this code in the planning section, so I can actually code. Right, and we're just gonna follow the code basically. So first off, we gotta make this if statement. So if yeah, how are you even gonna check if length of linked list is less than equal to 2? Wait, how are we actually gonna check? I think we have to do this first. So I mean that's a good way. We can say like if even dot next if not even dot next or not even, then just return head, I guess. Right? Yeah. Just return head. Yeah, that makes sense. So if not even dot next. Oh no, we still gotta initialize the odd and even. Okay, so odd is equal to odd and even, they're both equal to head and head dot next respectively. And then we can say if not even dot next. I think I gotta check if even first or not even dot next. Then we're going to return that makes sense. Then return head. And then we can iterate through the linked list. But first off, we need to if it doesn't pass through this if statement, then we can basically make what was it called? Even head. The even head is equal to even. Yeah. And so now now we can iterate through our linked list. So we can say while even and even dot next is true, we're going to make odd dot next point to even dot next, and then we're going to make odd go on to what's pointing at. So we can go through the other iteration if we need to. Then we do the same thing where even dot next points to odd dot next, and then even will point to even dot next to move on. Then once we're out of that while loop, we can say that the odd dot next is equal to even head, and then we're going to return head. So that should work. We already kind of demonstrated our code, our pseudocode, and we realized that we implemented that into the actual code. So we can just make our we can make our case, our test case. So I'm gonna use this one. 1, 2, 3, 4. So head 1 is equal to list node. the value of 1, and then head 1.next is equal to list node. I'm just gonna keep going. Yeah, so we made our test case. Now it should look like 1, 3, 2, 4. But before that, let's just go ahead and kind of make a print list class. Function. This print list class function is going to get a head. We can say that root is equal to head, and then we can say while root we can just print dot val, and then root is equal to root dot next. Yeah, and then I'm just going to call in our driver. I'm going to call get rearrange list. Call it with head. You call it head 1, and then call print list with head 1. So it should print out the rearrange list. So I think it should work first time, hopefully. Let's try it out. What? Requires 1, oops, 0, and then okay, cool. This is 1, 3, 2, 4. Okay. What about 5? What if we add a 5? Yes, yes. I want to make it look better, so and then n is equal to 5, 2, 4. Okay, cool. So it does work. Wait, was that the case? 1, 3, 5, 2. Hell yeah. Okay, so this works. So let's go copy paste it here. Run. Okay. Run type has no attribute next. For what case? Okay, I guess I can say like, so I guess I can say like, so if not head, then I can just say return none, right? Right? I'm pretty sure I can do that. So if not head, then return none, right? Yes, I did it. Yo, that's like first try. Hell yeah. Yeah, to review its complexities, we already know that's of one space, one extra space, because we only use like 3 pointers, an odd, even, and then another pointer to kind of like be like a second head, I guess. And then for time, it's ov n, because we're basically going through every element within the list, within the linked list to solve this problem. So yeah, very happy.